There's something called preconditions. I'd love to see your hands off the mice. You shouldn't be like using the computer right now. Look up here. A precondition is a required state that must be true before code executes. So, for example, this code returns the double result of two integers being divided. We could say that a precondition for this code would be that the b variable is not 0, right? Because you can't divide by 0. So that's an example of a precondition. And that term just shouldn't freak you out. The word pre means before, and condition means something that has to be true. Java will put the preconditions right above things in a comment, and you'll see that on the AP test. You probably saw it on the FRQ that we did the other day. I have those right here. It said the coin game No, they had little comments, but they weren't preconditions, so I was wrong. All right, so here's an example of a problem you might see, and look at this code and tell me what you think an appropriate precondition might be. So I'm asking you, what would need to be true if this code were going to run without crashing? And that would be called a precondition. I'm going to look at it now. August, you had your hand up first.
Yeah. You don't want string 2 to be longer than string 1.
So string 2 has to be the same length or shorter than string 1. Otherwise, it would crash. Because here we are saying, hey, let's get a piece of string 1, and we'll start at 0, and we'll go as long as string 2 is. And if string 2 was longer than string 1, then it would crash. So a precondition for this code would be that string 2 is, the length of string 2 is less than or equal to the length of string 1. Otherwise, this would crash. So you might see something like this in a comment. Precondition, 0 less than or equal to string 2.length less than or equal to string 1.length, which is a fancy way of saying string 2 is the same length or shorter than string 1. And they're both greater than 0. Well, or equal to 0, I guess. Probably it'd all work if they were all 0. You've got 3 precondition problems like this on our AP classroom multiple choice work we'll do next week. That's why I'm just introducing the concept. They're basically just saying what has to be true in order for this code to run without a crash. That's all. That's 5.3. Now 5.4 and 5.5. Java is designed as an object-oriented programming environment, and classes are the objects, and Java supports something called encapsulation, which means you let an object manage its own stuff. That's why we say private for all those variables. That means other code can't just go in and set the variables directly. If you want to give someone a way to set the variables, like we did with our student class, you have to make a method that says like set GPA. Or if you want to get the GPA, you need a method called get GPA. And these things that manage how the data is received and changed are called accessor and mutator methods. So I'm going to show you, here's something we could add to the rectangle class. Actually, it's already in it. Public void set width. I don't know if it's in it or not, but it could be added to the rectangle class that we used the other day. Check this out. It's a set width method. So you can make a rectangle and you can say, oh, I made it with the wrong width. So then you could, on the object, do dot set width and send over a new width. Now, check this out. This code is making sure that they're not setting the width to a 0 or a negative number, right? That would be a bad width for a rectangle. In normal universe, you can't have negative length. And it's not a rectangle if it's a 0 length, it's just a line. So this code makes sure that the new value sent in is valid before it sets it. Now, this is an example of the class taking care of protecting itself, like saying, all right, I'm going to ensure that my data my internal variables are fine, and I'm not going to ever let somebody set the width or the length to 0 or a negative number. So this is the sort of thing you can do. This is a mutator method, your first one that I've called it that, because it mutates it. It allows you to change the value of something stored in a class, in an object. We're going to go to the next slide. And this would be, if we had a shirt class, this is saying, hey, the only valid shirt colors are pink, red, and blue for this particular shirt object. And so you could say set color yellow, and it's just not going to change anything, because this is the class saying, hey, I know I can only have pink, red, and blue, so I'm not gonna let you set it to chartreuse. This is called data validation. When you do little checks inside your method or inside your code, make sure you're not setting the data to something wrong. So Java has two special types of methods. They look just like any other method, but they're called accessor methods that let you access data that's private. And then there's mutator methods that let you set data that's private. And you don't have to have these. But if you do have them, this is what they are called. Accessor methods are sometimes called getter methods, because you're getting information out of the class that you otherwise can't see, because the private variables you can't see from other code. Like, say I have a program over here and I create a book object. That's great. I can't talk to that book object and say, hey, tell me the author, like by sneaky around the back. I can't access the variable directly. But if the book has an accessor method that says get author, then you could call that and get the author. I'll give you more examples. So this is an accessor method example. It's as simple as just throwing the data back at the person. Public int get width, it tells you the width, return width. So that's accessing a private variable. And then a mutator method, this is setting the width to something. Mutator methods are usually void, because you don't have to send something back. Like if you say, hey, set the width to 7, the code's going to do it. You don't have to go, I set it to 7. You could reply yes or true or something, but it depends on how you want to write your code. But usually a mutator method doesn't send anything back, but an accessor method sends back the data you're trying to access. And accessor and mutator methods allow us as programmers to control who can see or change information in a class. And this is what I mentioned already, called encapsulation. And here's an interesting thing. Ideally in Java, you don't have to know how somebody else wrote their code. As long as you know the interface that you're allowed to use, you're allowed to create this thing. You're allowed to, you could be told what the methods are, and you could call the methods. And you don't have to know how they did their code. They could have written it in 100 lines. They could have written 1,000 lines. And as long as it's well tested and you all work together and make sure it works, that's great. Then you know your stuff, they know their stuff, and you call their thing. You can trust that it's working. Their code's encapsulated, your code's encapsulated. For example, with the rectangle and circle classes we talked about, it says before break. I don't know what that means. There's a get area method, and it tells you the area of the circle or the rectangle. We just trust that the circle or rectangle knows how to return the area. We don't need to double check. So most of the time we make all the methods in a class public. Sometimes you might make a method private. You consider it like a helper method, one you're going to use inside the class. So this is an example of that. I moved that color checking code into a separate little method called set color. And so for this shirt, when you create a new shirt, it goes ahead and calls set color with the color that the user's trying to create the shirt with. And if it's not pink or blue, it sets it to pink. So it's limiting the colors to pink or blue. You could send over yellow, but the constructor right here calls this method, and see, this method's private. It could be public, but you might as well, like if you're doing a shirt thing and you don't want people to be able to change the color, then you would keep this private. This is just my own little, this is where I put the code to check the color. You could put it in the constructor, but look how neat the constructor is. It's just like, hey, when they create a shirt, we just set the color. And then you put all the complicated stuff somewhere else. Sometimes it's really nice to have little complex pieces of code that are separate. Most of the time in the code we write, I can't think of a single assignment where I ask you to write a method that's private. But I want you not to freak out if you see it. It's just, it can be used inside of the class. Yes, August.
The private method can only be called by the class.
Yeah. Yeah, so I couldn't say shirt, new shirt equals Hayes shirt, and then Hayes shirt dot set color. It would say you can't access, private access denied.
You can only create a new shirt.
I can, for this code, all I could do as another coder is create a shirt and send over a color.
That shirt.
And it's going to be pink or blue.
Okay.
I could send it over with blue, or I could send it over with pink, and I could send it over with checkered, and it would set it to pink.
And you can just start writing that private method right inside the
It's just like any other method. It's inside the class. It's not inside the constructor. Here's the constructor, and then this is just another.
Could I call it other places in the class? Like, create another
Could you call it what?
other places in the class? Like,
Yeah, anywhere in the class. Yeah, you could have another, you could have a public set color. It couldn't be exactly the same name, but you could have another change color method, and it could call this one. Okay, so there's the list of all the work for today.